Hello everyone, today I will show the solutions to the Prairie Math League High School round 145, problems 5 and 6. For problem number 5, we have a classic problem. We need to find the number of trailing zeros in 2021. So basically 2021 factorial is equal to a bunch of numbers and then like some non-zero digit and then a bunch of zeros. And we wish to find this number. Now, notice that this is equivalent to finding the how many times can we divide this resulting number by 10. In other words, how many times, since 10 is equal to 2 times 5, this is how many times can we divide this number by 2, and how many times can we divide this number by 5. However, notice that since 2 is a lot more common, we can just go ahead and skip all the 2's, because 5 is the limiting factor. There's far less 5's than 2's in 2021 factorial. So, to do this, we consider all the numbers like 1, 2, 3, 4, 5, 6, etc. Let's say until like 24, 25, 26, 27. Now, notice that this counts for one multiple of 5, but a number like 25 counts for 2 of them, because this is 5 to the 1, and this is 5 to the 2. So, how do we count this? Well, we can consider this kind of like, just consider by rows. So first consider all the 5's that appear. Then we consider all like the 5 squares that appear. Notice that this only counts this kind of sum once, because we counted once in the first part and then once in the second part. Hope that made sense. But anyways, for the number of multiples of 5 to the 1, we take all 2021 numbers and filter out the ones that aren't multiples of 5. So this basically means finding the floor of 2021 over 5, which is 404. Now we count the next layer, the ones that contain 25s. So this will be 25, 50, 75, etc. Now, this is 1/25 of all of the numbers in this range, or 2021 divided by 25 floor, which is 80. And we could continue on in this method until we ultimately stop here, because there's no 5 to the power 5 in 2021 factors. So we can add all these up and find the number of multiples of 5 to be 503. Now there's a short trick that I'm not going to prove here, and you might want to try it yourself, but it's much more applicable to contests, especially when you can't use a calculator. So here, instead of repeating this calculation from 2021, we can take this number, plug this in here, take this number, and notice we keep this 5 all the way, and so on. And we can sum these and get 503. Basically the same thing. So for the next problem, we have a spider with a bunch of socks and shoes, and specifically one sock and shoe for each of its 8 legs. So, and how many orders can the spider put its socks and shoes on, such that the sock must be put on before the shoe? Now, this kind of problem has already appeared. This is Prairie Math League High School round 137, problem 6. So you might want to refer to this video, which is on this channel as well, for a more complete explanation. The only difference being that in that solution has an ant with only 6 legs. Well, 6 legs. But anyways, it's the same thing applies here, so we can get this 16 choose 2. So among all the operations that we do, we choose 2 of them for a single leg, and the order is already fixed because this is the sock and this is the shoe, and we can do the same thing, etc. So we get this thing, which basically simplifies to this, or 16 factorial divided by 2 to the power of 8. Thank you for watching.